Conference will now be recorded.
All right, well, thanks everyone, and welcome to this month's Southern California Sector-Specific Drought Outlook. I'm Andy Hoyle, and it is September 25th of 2025. This is part of our Modernizing Drought Early Warning effort, where our vision is drought resilience for the nation's economic sectors. And what we're trying to do is to build a community here to co-develop early warning information that uses sector-specific perspectives using evidence-based drought intelligence. And this is part of our process here where we deliver monthly sector-specific drought scenarios based on the integrated and tailored monitoring and forecasting information that we have with regard to drought. So as part of our pilot here, we're focusing on 9 Southern California counties, and you can see this here in the dark outlines indicating California's counties. We provide several perspectives here, and you'll get to appreciate that as we go further in the presentation. But we do note that Southern California sits within the larger water resources of the Southwest United States, so we will highlight the entire region where appropriate. So we are in the second year of this Modernizing Drought Early Warning effort, and this is the second presentation of the second year. So today's the 25th of September, and we provided a briefing last month on the 8th of August, and those activities can be found at the website here with the QR code on this slide. We will do this several more times during this phase of our pilot program, and some of the future dates are indicated here. So we'll reconvene again at the end of October, and then we'll reconvene in the middle of December, and we'll do so. We'll skip November just because, and we'll combine November and December's perspectives just because of the holidays within that time of year. And then we'll resume our monthly cadence in January and February, and even beyond that as well. They're not indicated here just because we ran out of space. Now, when it comes to the sector-specific perspectives, we are asking questions about what questions do you have about drought and what are you considering? So what topics are you considering regarding drought and its cascading effects? And we'd love to hear your thoughts and perspectives, whether in this presentation here, in this forum, or also through email as well. Now, the briefing organization is as follows. What we'll do is to provide a global perspective, so global conditions relevant to Southern California sectors, then followed by a regional perspective where we'll outline Southwest U.S. conditions relevant to the Southern California sectors, and then finally get into the sector-specific drought outlook, focusing on water utilities, public health, and agriculture. We have several lines of evidence that we will present to support the scenarios that we've created. We're using observed conditions, the current state of the region from observations as of this morning, September 25th at 10 a.m. Pacific time, unless indicated. And there are some instances here where there is an unless indicated because relevant recent data wasn't available as of this morning. We use a lot of predictions, and we use our expert interpretations of them in order to anticipate the future. What we also do too is we use end of season outcomes. It's not really relevant to this presentation right here and the evidence we're providing just because the water year, the season that begins on October 1st, is really yet to begin. But this will become more of a part of our evidence basis here, where we're combined season to date observations and forecasts in order to be able to provide better predictions of the outcomes and their chances. Now, also when we provide our scenarios, we provide a confidence statement, whether it's high confidence, medium confidence, or low confidence. And this is pretty intuitive here. If you have high confidence, you have close agreement across all of your sources of evidence. And if you have low confidence, you just don't have much agreement among your sources of evidence, and therefore you're not very confident in the scenario that is being provided. All right, and the way I'll conduct this here is I'll provide the global perspective, the regional perspective, and the sector-specific outlooks. And every time that I finish a section, I will open it up to our audience for questions and comments. So moving in here to the global perspective, there are aspects of the Earth system that we use in order to try to better anticipate potential outcomes in the Southwest and Southern California. And we look no further than the El Nino Southern Oscillation. And so, as we call it, it's composed of El Nino, La Nina, and neutral phases. And it's related to weather anomalies that we use to predict conditions in California during many following months. The El Nino Southern Oscillation itself actually varies quite slowly. Once it's in a La Nina phase, it tends to stay there for several months, and its impacts are profound, which is why we can use it as a way of making some forecasts of the future. Now, as I alluded to just a moment ago, La Nina is forecast between late 2025 and early 2026, and this increases the chances for prolonging drought that's ongoing in Southern California through calendar year of 2026. Now, why is this? So when we have a La Nina event, what we end up seeing is these big effects on the atmosphere in the northern hemisphere. And with regard to La Nina, it creates these waves that move away from the tropics, and these waves organize in such a way in a rather predictable pattern. What we have is what's called a blocking high pressure off the coast of California that really alters the jet stream and the movement of storms throughout the southwestern United States. So as you can see here in the schematic, typical La Ninas are associated with below average precipitation in the southwest United States, wetter conditions in the northwest United States. And these really pertain to conditions during, say, October through May of the following year. Now, there are several different ways for us to be able to quantify the El Nino Southern Oscillation. We can use atmospheric circulation, we can use sea surface temperature anomalies in the tropical Pacific Ocean. And this perspective here happens to be what's called the Oceanic Nino Index. And what it does is it takes the sea surface temperature anomalies over the central tropical Pacific Ocean. Anomalies are simply just taking the value that we observed at a given time and subtracting from that a long-term mean. So getting an idea of how conditions are variable from mean conditions. So values that are positive are indicated by this red shading, values that are blue are indicated by this blue shading. La Nina is indicated by the blue shading here. And what we note here is that during 2020, 2024, and 2025, what we had is this borderline La Nina event. This borderline La Nina event being measured by this Oceanic Nino Index. However, what we've done in recent years is to be able to quantify this Oceanic Nino Index in the context of warming within the tropical oceans. And we've created indices to reflect that. This index right here is the relative Oceanic Nino Index. So if you're following this community right here, chances are you've probably noted that there are several ways to quantify El Nino Southern Oscillation in this day and age, and the relative index is one such way. The relative index just includes the warming of the tropical oceans. And you can see this right here where the 2024-2025 event, which is indicated in this yellow circle, it did not really look to be much of a La Nina event last year based on this index, this Oceanic Nino Index. But a slight modification to that index yielding this indicates that this was indeed a La Nina event. This right here is the perspective that is really becoming more normal within our community. It's becoming more adopted, and that's why we're showing it right here. Now, as it relates to forecasts of the El Nino Southern Oscillation, just because previously I showed that Oceanic Nino Index and that relative index, I'm going to show forecasts of this right here. So these are forecasts of September 2025, October 2025, all the way to February of 2026. These are from several different forecast models, and what they're quantifying here is the departure from average of this Nino 3.4 index. What you note here is that all of these models are forecasting negative values, meaning below average sea surface temperatures, and thus a La Nina event extending from really October all the way into early next year. Now, if we include that relative perspective, where we include information on the warming tropical oceans, what it looks like right here is that this La Nina event is that much more intense and more prolonged. So including this relative perspective, where we take into account not only the El Nino Southern Oscillation itself, but the ocean that it sits in terms of its warming, what this indicates right here is that we're expecting a stronger and longer persisting La Nina event. And this is going to be reflected in several forecasts and several perspectives that are shown in the following slides. Now, our colleagues at the NOAA Climate Prediction Center, what they do is at several points in the future, they assign what they feel are the probabilities and the chances of La Nina, ENSO neutral, and El Nino. And this chart right here indicates the probabilities of La Nina in blue, ENSO neutral in gray, and El Nino in red. So for 3-month seasons like September, October, November, indicating the probability of La Nina being the most likely outcome. that indicating right here that La Nina is the most likely state of the El Nino Southern Oscillation for late this year and into early next year. So we really have a convergence of evidence based on expert interpretations like what are being shown right here on this slide, in addition to forecast models that we use that a La Nina event is most likely late in this calendar year of 2025 and into early 2026. Now, I'll get into the regional perspective here, and then I'll stop for some questions in just a little bit. Now, the takeaways from the current drought. Drought continues across Southern California and the Southwest United States. We are in the second year of a drought. Drought's been ongoing since late in calendar year of 2024, and it's been quite persistent and intense over the last number of months. Now, the reason for this is since October 1st, and this extending to a period of September 8th. This was the third driest and the eighth warmest such period in Southern California since 1951, where Southern California is defined by the 9 counties that I showed in a prior slide. The reason why we stopped on September 8th is because this is when a key data stream has been updated since, meaning that it's not operational at the moment and will be offline for a little bit longer. This is not reason to fear anything. This is a normal downtime in terms of operations and improvement. So this isn't to be interpreted as anything but that. But during this period that's shown here, third driest and eighth warmest. Also over the summertime of 2025, this is for June to September, daily maximum temperatures were above average in Southern California, and this is particularly so in San Bernardino, Riverside, and Imperial counties. So we'll begin here looking at the U.S. Drought Monitor. So the U.S. Drought Monitor, what it does is it considers several different types of droughts and its impacts, and it assigns several drought categories: moderate drought, severe drought, extreme drought, and exceptional drought. So the orange and red colors on this slide indicate that. There's another category called abnormally dry, which is in yellow, which is technically not drought, but it's close to it. That's shown here in the upper panel in space, where we can see across much of Southern California, almost the entire area is covered by drought. So you can see that for the total area in drought, 91.3% of this 9-county region was undergoing drought on September 23rd. Now, abnormally dry conditions covers 8.2% of the region, and this really just covers here much of San Luis Obispo County and northern parts of Santa Barbara County. Now, if you add all of these up, this is 99.5%. The only 0.5% of the region that is not under abnormally dry conditions or drought is this real northwest part of San Luis Obispo County. The bottom panel here is the total percent land area in these different categories of drought and abnormal dryness. And looking ahead and looking right here at the 2025 year, we note that since the beginning of this calendar year, almost the entire region has been in the throes of drought, and significantly so. And this drought has really persisted throughout much of 2025 into the current day. Now, the reason for this right here is because precipitation has been below average and temperatures above average across almost all of Southern California and the southern half of California itself. And you can see that much of Southern California endured about less than 50% of average precipitation for the period of October 1 to September 8. On the right here, this is temperature departures from average, and noting here that almost all of Southern California has endured above average temperatures in this almost 12-month period. Now, if we're going to plot these together and look at the compounding nature of this, that is having 2 extreme events at one time over the 9 counties that include our area of Southern California, you'll note here that this year, this current water year, is the 3rd driest on record, and that this period, October 1 to September 8, was the 8th warmest such period in Southern California. So a really exceptional extreme event that we've seen over the last 12 months, resulting in some pretty exceptional drought. Now, just to better summarize and better contextualize temperatures, summertime temperatures over Southern California have been above average. So all told, for the entire region, it's the eighth warmest water year so far, and it's also been above average since June, so June 1 to September 9 of 2025. What you will note here is that over some areas, really a little bit away from the coastline, but for those counties that are along the coastline, like Santa Barbara and Ventura and Los Angeles, There has been some below average daily maximum temperatures, however, in the southeastern parts of the region, like San Bernardino, Riverside, and Imperial. It's been quite warm. And these happen to be the areas where they're the warmest parts of the region, anyways, where daily average temperatures exceed 100 degrees Fahrenheit. And these temperature departures, as in the variations from the average, are along the lines of 2 to 3 degrees Fahrenheit. So, pretty significant in that regard. Now, one thing to note here is that last week there was a precipitation event that went through Southern California. Unfortunately, precipitation events like this during the summer, they don't provide a lot of benefits in terms of like drought amelioration, but they do provide some issues in terms of the consequences from them, like mudslides. So for instance, a lot of these elevated areas in the interior parts of southeastern California, there was heavy precipitation. This is noted here based on the color bar that's shown on the right. Unfortunately, they fall on a really dry land surface and they lead to significant mudslides. And there's been some reports out of Southern California along these lines. So this precipitation event that was observed last week did not do a good job or did not do much in the way of alleviating drought, but it was a pest and a nuisance because it provided impacts with regard to damaged infrastructure. And I think even a couple people were missing as well. Now, getting into the forecasts that are relevant to drought. Drought is expected to persist in the Southwest through at least the end of December of 2025, and this is according to our colleagues at the NOAA Climate Prediction Center. The reason for this is above average temperatures are forecast in the Southwest during October to December of 2025, December to February of 2026, and March to May of 2026. And in addition to that, below average precipitation is forecast in the Southwest during December to February of 2026 and March to May of 2026. So the forecast precipitation and temperature are not looking good, and this right here, in a most likely sense, will prolong drought into and through 2026. Now, one thing that I did want to focus on a little bit before we get into the more longer range forecasts is that precipitation is forecast over the next several days over Southern California through this coming weekend. And you can see this right here in terms of the precipitation amounts where some light precipitation is forecast to fall, especially in southeastern parts of California. This, like the event that we saw last week, is not expected to really relieve drought conditions. And depending upon how heavy the precipitation may be, it may be more of a nuisance than anything else. So this precipitation that is generally supposed to be light in nature is not forecast to alleviate drought conditions. There's another chance of precipitation in the middle of next week, but that would also be along the light side as well. Now, looking in terms of more longer range forecasts, this right here is from the NOAA Climate Prediction Center, and this is where how drought has persisted to persist, improved, end, or develop through December 31st of 2025. And in the Southwest and in Southern California, there is overwhelming odds of drought persistence across almost this entire region here. There's an area that is under drought right now, where drought is forecast to end by the NOAA Climate Prediction Center, though I would say that that's a pretty uncertain forecast at this time. So folks will just have to watch very closely as that evolves. Now, the next several slides will show the seasonal precipitation and temperature outlooks from the NOAA Climate Prediction Center. So on the left, the chances of below normal precipitation are indicated by brown colors. The chances of above normal precipitation are indicated by the green colors here. And there's actually a near normal probability that can be shown in these maps, but they are very rarely expressed like that. On the right here, the same nomenclature, the same style for temperatures, where red colors indicate chances of above normal temperatures, blue colors, chances of below normal temperatures. So for October, November, December, not much of Southern California is really getting into this area of enhanced odds of below average precipitation. It's more confined over the Southwest United States. However, above average temperatures are forecast to the tune of about a 40 to 50% probability over Southern California and much of California. Now, as we move into December to February of 2026, this is more of the heart of the wet season in Southern California, and there's elevated odds of below average precipitation in Southern California and the Southwest. And in addition to that, there's elevated odds of above average temperatures as well. And this being here from March to May of 2026, more of the same. elevated odds of below average precipitation in the Southwest and specifically Southern California, and elevated odds of above average temperatures as well. And that supports a drought outlook of drought persistence as we go through the end of the year. And if we were to extend that drought outlook into the spring of next year, it would indicate that the drought that we're currently in, that's 1 year old, would go through a second year. Okay, well, that's a lot of material, and I appreciate you all for listening to it. Are there any comments or questions on what we've just presented?
Andy, there's one in the chat. Would you like me to read it or?
Sure, I can go ahead and take a look at it.
Why don't you read it out loud just for the sake of the recording, though, please?
Sure, I can do that. This is the question states, for the NOAA CPC ENSO probabilities, do those incorporate the relative oceanic Nino index in the forecast models that you showed earlier? Technically, no. They are based on the oceanic Nino index because that is the operational index that they use by definition. That said, humans can't forget what they've looked at and forget what they've learned. So perhaps that makes its way in there, but no, by the letter of the law, it does not allow for the relative index to be used because it is not the operational definition. And if you'd like to follow up on that, Annie. Oh, there you go. Thank you. Okay, well, hearing no more questions, we will move on here into the water utilities sector. I think one thing you'll note here, if you watched our presentations from last month, is this is more of an incremental update than it is a large-scale update because the water year, the precipitation season, has yet to begin in earnest, and big changes can occur within these outlooks sometime in the time frame of like a October, November, December. But right now, as we go into the beginning of the precipitation season, we don't expect there to be big changes, and indeed there are not. So in terms of the water utilities scenario, reservoir storage and groundwater levels are expected to be lower in June 2026 compared to September of 2025. Now, mind you that June 2026 or 2020 or June in general is the time of year when reservoir storages reach their maximum for the year. And they reach their maximum, that's because that's when snow has generally melted off, made its way into rivers, and then finally into reservoirs. So the supporting evidence here is that increased chances of below average precipitation and above average temperatures between September of 2025 and May of 2026. And this is due to the forecast La Nina late this calendar year and early in the next. The second point here is increased chances of below average snow water equivalent on April 1st, 2026, due to the forecast La Nina in late this year and early in the next calendar year. And then finally, the Bureau of Reclamation projects lower inflows into Lake Powell in the next 2 years. So we begin here with looking at reservoirs from California Water Watch, and this is as of the 23rd of September. Noting here in Southern California that reservoirs are generally near average. They're lower now than they were last year, just because precipitation was quite a bit below average and we've been in the throes of drought. But there is quite a bit of memory and persistence in reservoir levels, and thankfully they're in this condition and not worse. This right here, according to the scenario that we provided, we would expect them to be less next year than this year. This here is groundwater, and groundwater, again, according to the California Water Watch, is mixed across Southern California here, quite a bit below average in Santa Barbara County, but there are other counties as well where we're seeing conditions that are closer to the normal, around the 50th percentile or so. Further north you go out here into our Southern California counties like San Bernardino County, noting here that conditions are actually quite low in terms of groundwater. Now, the principal line of evidence beyond the forecasts that we looked at that were provided by the NOAA Climate Prediction Center are the chances of seeing below average precipitation and above average temperatures during La Nina events compared to non-La Nina events. So the way the left-hand map was constructed here is we took La Nina events, which we feel are analogous to the season that we are currently going to enter. We computed the probability of below average precipitation. And then we compared that to the probability of below average precipitation during non-La Nina events, and then computed the percent difference between the two. So 20%, 40%, 60%, 80%, that just indicates a 20% increase in the chance, a 40% increase in the chance, and a 60% increase in the chance of below average precipitation related to La Nina. The opposite is also true, where a minus 20, minus 40, minus 60 indicates a decreased chance or a decrease in the odds of below average precipitation. Now, what you'll notice here for September through May related to La Nina is almost across the entire southwest United States, and this includes Southern California, that there's a very large increase in the odds of below average precipitation during La Nina events compared to non-La Nina events. That right there also supports forecasts that we showed previously. On the right, same perspective, but for above average temperatures. And as you can see, there's a very high likelihood or a big increase in the chance of above average temperatures during these La Nina events compared to non-La Nina events, with the highest chances occurring here over much of the Four Corners region and southeastern California as well. Now, because of below average precipitation and above average temperatures, we tend to see low snow water equivalent on the 1st of April, and this is shown here for several past La Nina events. In the upper left, this is 2012, 2018, 2021, 2022, 2023, and 2025. And you'll note that throughout much of the southwestern United States, these warm red, orange colors indicating low snow water equivalent in the southwest on April 1st, which diminishes water resources and water that makes its way into reservoirs to be used at a later date. Really, the outlier here is the 2023 year, where we saw exceptional precipitation in the southwest United States several times during this season. And Southern California and California in general was certainly under the gun for that. This can happen. We might go through this season and we might get the low likelihood outcome where we get exceptional precipitation and fantastic water resources like 2023. Unfortunately, based on historical records and historical context, that is not a likely outcome, but it is nonetheless a possibility. And if we are rooting for something, that's what we're rooting for here. This right here is from the Bureau of Reclamation. And what it does is it provides projections of the pool elevation of Lake Powell. The black line right here that begins in February of 2025 and goes to September of 2025 indicates the observed pool elevation. These colored contours here, they indicate the probable maximum, most probable inflow, and probable minimum inflow at some future time out to 2 years. And this is based on a 7.48 million acre feet release in water year 25 and water year 26, in all three of these scenarios. But all three of these scenarios also incorporate historical information. So they take all of the observed history that's available to the Bureau of Reclamation, and then they put these together, these scenarios. This green line right here is the most probable, being the middle of the distribution of possible outcomes right here. The red is on the lower end, so it's the minimum of all those historical outcomes. And the blue line right here is the highest. It's the maximum of all those outcomes, those historical outcomes. Unfortunately, because below average precipitation and above average temperatures is most likely, we would most likely fall somewhere on the lower end of this curve right here. So the blue curve is not likely. It's not likely just because we're not anticipating an above average precipitation year, but rather a below average precipitation year. And we would expect to fall somewhere in the lower end right here, which is supporting our perspective of having lower pool levels and reservoir levels come June 2026 compared to where we stand right now. Okay, well, this right here is the water utilities scenario, and I'd welcome any comments or questions if folks have any. Okay, well, hearing none, let's move on here to our next sector, which is public health. So here's the public health scenario. So in Southern California, poor air quality is expected in October to December of 2025 and April to June of 2026 due to smoke from wildfires. We have high confidence in that, particularly so for October, November, and December. And in March, June 2026, we expect poor air quality due to blowing dust, and there's medium confidence in that. The reason why we only have medium confidence is because it's a longer lead forecast. It's so many months in advance that it'd be really difficult to assign a high confidence forecast to it at this moment. So the supporting evidence here is that we have an elevated risk of significant wildland fire potential in Southern California through the end of 2025. Also, in March to June of 2026, we're expecting intermittent high winds blowing over a dry land surface related to below average precipitation during the 25-26 wet season. And then finally, below average precipitation and above average temperatures in 2025 to 2026 wet season increases wildfire risk in the spring of 2026. I did want to touch on this real briefly, just because it affects vegetation workers who are in the fields for agriculture. And just noting here that temperatures were above average in southeastern California, where there's quite a bit of agriculture. Some areas to the west did see below average temperatures since June 1st. A little bit of a unexpected outcome, a welcome outcome, because it's better than the alternative. But nonetheless, there were some areas of very high temperatures in the southeast, and those happen to align with the hottest areas of California. Now, this is the air quality index and wildfires as of this morning. And we note here that in Southern California, there's some areas of poor air quality in those urban centers, but not seeing much in the way of wildfire activity across Southern California. That's a good thing to see. We don't need fires, and we don't need reduced air quality here. And this is in contrast to last month, where there were fires that were burning. But the recent precipitation, if there was some benefit to them, they did help to put out some fires in Southern California. This right here is the significant wildland fire potential outlook. This is from the National Interagency Fire Center Predictive Services, and this is an interagency center that includes the Forest Service and NOAA and several other agencies. And what they do is they assign above normal, below normal, and normal conditions of significant wildland fire potential, where the red colors indicate above normal significant wildland fire potential. The left is October of 2025, the right is December of 2025. And as you can see in Southern California, along all these coastal areas and even somewhat inland, that there's an increased risk of significant wildland fire potential through December of 2025. These are forecasts were issued on September 1st, and their next issue will be on the 1st of October, so just next week. Now, there's several quantities that we use in order to monitor and forecast the potential for significant wildland fires. One such measure is called vapor pressure deficit. Vapor pressure deficit is simply the difference between how much water the air is holding compared to how much water the air can hold. So when there are positive values, what that indicates is that the air can hold a lot more water than it's actually holding. And when that happens, the air wants to take moisture from some source. So in the absence of an ocean, it will rob moisture from the land surface where it does exist. So when we have higher vapor pressure deficits, it means that there tends to be an increase in the risk of wildland fire potential, just because vegetation won't have as much water as it typically would have. So here what you're looking at is the probabilities of above normal and below normal vapor pressure deficit. And this is valid for a period of October, November, December of 2025. And here over Southern California, very high probability of above average vapor pressure deficits, up to about an 80% probability. So this, in forecasts like this, are being included in the perspectives that the National Interagency Fire Center is putting out, and I showed that in the prior slide, and really helping to support the forecasts that they have produced. Now also, I showed similar perspectives as this previously, but this here is not for September to May like I showed before, but it's for September to November. So this is September to November, change in the chances of below average precipitation and above average temperatures during La Nina events compared to non-La Nina events. And as you can see, there's an increase in the likelihood of below average precipitation and above average temperatures during September, October, and November. That right there is a time of year where we can see Santa Ana winds. And those winds, when they do kick up and there happens to be a spark along a dry land surface in the absence of any material precipitation, that can lead to situations where there's widespread wildfires. something similar to what we saw last December and January in Southern California. So there is a chance and there's an increased risk of conditions like that as we move later in this calendar year. Also for December, January, and February, much more of the same. Increased chances of below average precipitation, increased chances of above average temperatures, and this is related to La Nina, comparing this to non-La Nina events. Also looking at winds. What this does right here is it takes the 9 counties in California and it computes the distribution of wind speeds, daily average wind speeds, as a function of time of year. And this is daily data spanning October all the way into the following September. One thing to note here is that wind speeds tend to increase by the time we reach spring. So this includes March, April, May, and June. So this is part of the reasoning behind looking out for increased blowing dust and any ailments that may be related to increases in blowing dust, like valley fever, for example. So wind speeds tend to increase during the spring in Southern California over the areas that we expect to have a dry land surface that can kick up dust and can lead to airborne contaminants in particulates. So that wraps up the public health scenario. And if folks have any comments or questions, we'd love to hear them. Okay, well, hearing none.
Annie raised her hand.
Oh, Annie, go ahead.
Thanks, Andy. I was wondering if you could talk about like what data source you would recommend for precipitation forecasts so that we could prepare for high precipitation events like what just happened in San Bernardino.
Yeah, that's a great question. There are many forecasts that are out there. The Center for Western Weather and Water Extremes, CW3E, is a great source. They've got fantastic maps that provide a lot of information, especially on heavy precipitation. The National Weather Service has a lot of information regarding extreme precipitation over the entire United States, and obviously you can find maps in the Southwest. Those are personally 2 of the sources that I use for that purpose. Yep. Thank you, Eleanor. Yeah, you're welcome, Annie. Okay, let's move on here to agriculture. So it follows that below average precipitation, above average temperatures would lead to reduced agricultural outcomes, and that's reflected here in the scenario. So crop stress, which may reduce agricultural productivity, is expected through at least spring 2026 in Southern California due to a second year of below average precipitation and above average temperatures, especially during the dormant season post-harvest. The supporting evidence here is current low soil moisture in Southern California is forecast to persist, and below average precipitation and above average temperatures in Southern California are most likely between September 2025 and May of 2026. This chart right here indicates the annual rangeland forage production, so its growth rate in units of pounds per acre per day, and it's shown in terms of month, so from October all the way through September. What you note here is that there's some minimal production between October and February, but really prime time takes over in March, April, and May. The California growing season is actually a fair bit different from that of the rest of the United States, and that should be noted here. So tailored perspectives to California would be much appreciated because they do contrast much of the perspectives that have been developed for the rest of the United States. Unfortunately, conditions lately have not really been very good in terms of agriculture. So this right here is the evaporative demand drought index, and it's shown in terms of percentiles, where the redder colors indicate more demand of water by the atmosphere, the bluer colors indicate less demand of water from the atmosphere. It's very similar to the perspective that I showed previously in terms of vapor pressure deficit. So in terms of the evaporative demand, this is just charting how thirsty the atmosphere and how it's demanding moisture from the land surface. You might ask how vapor pressure deficit and the evaporative demand drought index are related. Vapor pressure deficit is one aspect of the evaporative demand drought index. There's several other aspects as well, like wind speeds, solar radiation, and there's one more term as well. So these colors here are indicating that there has been quite a bit of demand of moisture by the atmosphere from the land surface. I will say, if there is a silver lining here, when I presented this map last month, the entire map was that deep ruby red. At least this month, it's not that deep ruby red. It's a little bit better than it was, but it certainly is not a good situation in terms of drying out the land surface. Now, speaking of the land surface, this right here is soil moisture percentiles on the 20th of September. So when you see red colors, it indicates low soil moisture compared to a historical record. The green colors indicate high soil moisture compared to a historical record. And over Southern California, you'll actually note some areas where they're greens, where there's there's higher soil moisture. That might be a little bit misleading. Heavy precipitation events like we saw last week can give these high soil moisture values for a very short period of time. So what I would expect here is that by the time we get a few weeks from now, that these values will not be green any longer. They'll probably reverse course and move in the direction of the reds, indicating low soil moisture percentiles. In terms of soil moisture forecast, this is provided by our colleagues at the NOAA Climate Prediction Center, and what they indicate is the most likely soil moisture percentile by February of 2026. So this forecast was generated on September 10th, and what it does is it takes land surface conditions, similar to the conditions that are actually shown in the slide on your screen right now, and then forces that land surface model with forecasts of precipitation, temperature, solar radiation, and other quantities that are important to soil moisture. Runs that to some future period, in this case, February of 2026, and then generates what the most likely soil moisture percentile is to be, and indicating over Southern California and Southeastern California that by the end of February 2026, that low soil moisture is most likely by that time. And you've seen similar perspectives as this several times in the presentation, so I won't dwell too much, but indicating that for September to November, we're calling for an increase in the odds of below average precipitation due to forecast La Nina event. Same for temperature, indicating an increased likelihood of above average temperatures. Also pertaining to December, January, February as well. Increased likelihood of above average temperatures and increased likelihood of below average precipitation. And then finally here, increased likelihood of above average temperatures and below average precipitation during March to May. So all things considered, not a great situation, a great forecast for agriculture in Southern California. So that right there concludes our agriculture scenario, but also concludes the presentation. So if anybody would like to provide some comments or questions on agriculture, we'd love to hear them.